Welcome. We would like to use Gaussian elimination and back substitution to solve this system of equations. Now, Gaussian elimination just has us rewrite this system of equations in triangular form. This is very similar to what we had done in the previous section, where we looked at systems of equations with two variables and two equations. There, we simply used the addition or elimination method to create one new equation that had only one variable in it. And what we're going to do is kind of record or keep track of a collection of equations to create this triangular form for a system of equations. What I'd like to do is I'd like to keep track of each equation in each step. So for each step, I'm going to label my equations A, B, and C. Some texts have you label each new equation a new letter. What I'm going to do is I'm going to simply reference the first, second, and third equation as A, B, and C, regardless of what iteration we're on. So if I want to write this in triangular form, I'm looking to get rid of these x's, and these y's. This will give me an equation that has just z, an equation that has y and z, and an equation that has all three x, y, and z. In order for us to do that, what I'm going to do is I'm going to add equations together in order to eliminate these variables. What I need to do is I need to keep track of the manipulations that I'm doing, so that way my communication is clear in what manipulations are being done. So for example, if I want to eliminate this x, I can do that by adding the first two equations together. So I can take equation A. Actually, what I'd like to do is I'd like to take equation B and I'd like to add A to it, and that will eliminate this x. I'll draw an arrow. The arrow is probably not necessary, but B plus A gives me, is what I'm trying to communicate in that. Gives me a new system of equations. So by writing B first, I'm saying I'm manipulating equation B. How am I manipulating it? By adding A. So equation B is the one that I'm changing. I'm taking this equation and adding equation A. So to combine like terms, negative x plus x gives me 0 x's. It's gone. 0 x's. I don't have to write it down, but it's a nice placeholder for the moment. 3y's plus a negative 2y's gives me just 1y. Z plus 3z gives me 4z. Negative 2 plus 9 gives me a positive 7. Now, that's what I've done to the second equation, but I haven't changed the first or third equation at all. So I'm actually just going to copy those down, rewrite them. I still have x minus 2y plus 3z is equal to 9 for the first equation. X minus 2y plus 3z is equal to 9 for the first equation. And for the last equation, I still have 2x minus 5y plus 5z is equal to 17. Now what I'd like to do is I would like to get rid of this value, or these x's here. So again, referring to these as equations A, B, and C, what I would like to do is I would like to take equation C and manipulate this equation. How am I going to manipulate it? Well, I'm going to subtract 2 times equation A. I'm going to subtract 2 times equation A. The resulting system, this minus 2 of those, will eliminate the x's from the third equation. Now, usually what I do is I actually copy down all the preceding equations. So typically, I copy down the first equation when I'm not manipulating it. X minus 2y plus 3z is equal to 9. The second equation I am not manipulating here. So I have 0 x's, I have 1y, I have 4 z's. This is equal to 7. And the third equation is the one that I am manipulating. I am taking this equation and subtracting 2 of those. 2x minus 2x gives me 0 x's. Negative 5y minus 2 of those. Here it requires some mental math. Some people write down each of these additions, which is fine, but that side work, you could write it over to the side. the main work here should just contain the manipulated systems of equations. So I have -5 minus 2 times -2. -2 times -2 is a +4, so I have -5 plus 4 gives me -1. This minus 2 of those, 5 minus 6 is a -1, so I have a -z. And this minus 2 of those, 17 minus 18 gives me a -1. This I will still label as equation A, B, and C. So now I have completely eliminated the x's from the second and third equations. And I just need to eliminate the variable y from the third equation to be in that desired triangular form. So I'm going to take, see, I wrote something down wrong. I hope that I said it right, but I wrote it down wrong. Oh, no, I did write it down right. I'm sorry, I thought I manipulated the second equation. We're good. I manipulated the second equation. I manipulated the third equation. Okay, yes, excellent. I want to manipulate the third equation again here, get rid of this variable y. So I am taking the equation C, the third equation, and I'm going to add to it equation B. Again, I'm writing this in a very particular order. The first equation that is written, B, C, C, is the equation that I am manipulating. What follows is how I am manipulating it. Equations A and B are staying the same, so I still have x minus 2y plus 3z is equal to 9. I still have y plus 4z is equal to 7. And the third equation is the one that I am manipulating. I'm adding these two equations together. Negative y plus y gives me 0 y's. Negative z plus 4z gives me 3z. Negative 1 plus 7 gives me a positive 6. Now I have this triangular form. And I can use the method of back substitution. 3z is equal to 6 gives me that z is equal to 2. Now I plug that back into the equation above. I have y plus 4 times 2 is equal to 7. I can subtract 8 from both sides to find that y is equal to -1. And now I have x minus 2 times -1 plus 3 times 2 is equal to 9. So I have y plus 2 plus 6 is equal to 9. In this case, I can subtract 8 from both sides to find that x is equal to 1. This gives me the solution, x, y, z is equal to 1, -1, 2. So again, the process that we have followed here is Gaussian elimination to write it in triangular form, and then back substitution. We'll take a look at another example just to solidify the idea of writing in triangular form and back substitution.